In physics, kilogram is the unit of mass. All right. It's not weight. So what does that mean? What do you mean by unit of mass? What is mass? So this is where you've got to understand it so well that when I give you a question, you're not thinking like, and you're not giving me a general answer. The unit of mass, and what I mean by mass is how much stuff or matter I am made of. Okay? I am made of. Now, as you said, I think Michelle was kind of the closest at 90 kilograms. I'm hoping I'm 95 kilograms. So that is how much stuff I'm made of. That includes my arms, my legs, my head, everything. If I go into space or if I go to Mars or Jupiter, I'm still made of the same stuff. Right? The matter that makes me up hasn't changed. So in physics, kilograms is a unit of mass. So what's weight then? Right? Weight is, now I'm going to try to keep it real simple, is the force due to gravity. Right? And it's how much I'm being pulled down towards the earth. All right? And it's gravity doing that. Gravity is pulling me down to the earth. So I'm actually going to add some of that. Gravity is pulling all of us right now towards, now I want to be kind of pinpoint on this, towards the center of the earth. It does not pull us down. And we actually ask exams questions like the center of the earth. We actually ask exam questions like this. And what we'll say is, which way are you pulled? Or, we'll word it in a way, we'll give you a diagram. And we are pulled towards the center of the earth. And, well, why can't we accept that we're being pulled down? Pulled down means we are pulled in that direction. And if you're on the other side of the world and you're in Australia, that way means you're falling off the earth. All right? And we know that doesn't happen. I've got friends in Australia and New Zealand. I know they're not screaming like little babies and holding onto the table as they fall off the earth. So let's just be kind of careful with that. So what's the difference? Kilogram is the unit of mass. Weight is the force due to gravity. We're always being pulled down towards the center of the earth. All right. So I'm going to give you a little kind of formula. Now, we're still talking about units. I love units. The unit of force is the Newton. All right. And how we work out our weight is by a really cool formula, which is W equals mg. You can barely see that. Let's do it. So what this means in words, so if you're ever asked what is weight, so you're going to what is weight, you can actually write down in your exam, weight equals mass times gravity, little g. All right. On Earth, and I'm very careful about this because we can be anywhere. On Earth, this is 9.81. You can round it up to 10. I like 9.81. Okay. It can be, you can have lots of different units for this. This is newtons per kilogram, or it's meters per second acceleration due to gravity. We're okay with newtons per kilogram, and there we go. So what I'm going to, everyone's at different points, all right? Some of you may be, obsessed with science like I am, and you spend your face in a book, and, and to me, things like forces and non-contact forces are really interesting. Gravity is always attractive. We're always pulled down. There's no repulsion. It doesn't work in the opposite direction. If we did, oh my God, can you imagine what it could do to the world? One of the biggest problems we've got on this planet is transport. Right now, I'm in the UK. I'm up in the Pennines. It is cold, and it ain't no way we're growing oranges. I love oranges. We can't grow them, so we ship them in. The biggest burden shipping things in is the fact that they're heavy. If you could create an anti-graviton particle, an anti-gravity field that actually repels, you cut down the damage we do to the earth, and I can still eat oranges. Anyway, Okay. So the second part, so those are two things that I'm looking at. But the main thing, and the other part of it is, well, how do we learn this language of physics? How do we learn anything? And some students are in year 10. And you've got exams next year and things like that. So how do we learn things? So some students, what they'll do is they'll make notes. Some students will read notes. Some students will get the CGP textbook and start reading through it. That is actually one of the worst ways to study. Right? So what I've done is I've got some flashcards here, and these are on websites. I didn't know I could do this, so I've learned how to do this. So what you can do, if you click on this, and the order in which you work is down here, and if you get this far, right, we've got some calculations we can do, but it really doesn't matter. I'm not concerned about how far you get. I'm concerned how fluent you get with the language of physics. Okay. So you click on this. There's a little source button there. You press on it, and you come to these flashcards. What is a force? And what you do with the flashcard is you try to answer it in your head. And you flip the card and it says a push, pull, or twist. All right, yeah, fine. Whether you got it or not doesn't matter. You go to the next one. Give me an example of a push force. Oh, me pushing a box on the ground. Flip card. Pushing a swing. All right, I get that. Next, give an example of a pull force. Tug of war or pulling a door open. Give an example of a twist force. And you check it, opening a bottle or turning a doorknob. What force is responsible for the compass working? We're not talking about the things that you draw a circle with, ones that tell you north and south. And that will be, hold on, here I come, magnetism. What object causes forces to fall down the ground? So you're going to go through this, and then what a lot of you will do is you'll go, right, I've done it once. You need to go through it about 5 times. You need to, and it doesn't matter how fast you go through it, but you need to go through it at least 5 times. And then what your job is to do is go back here and answer these questions. Now, the first 6 are relatively easy. Number 7, I will know that you've rushed it and thought, oh, yeah, I don't need to do that. Becoming good at something means perfecting the fundamental basics. All right. I'm lucky. I teach really high level maths. I teach A level maths. I teach A level chemistry too. I teach chemistry. Actually, I taught chemistry to undergrad dentists at Bristol University a couple of years ago. So I teach at a really high level. And I know the students who are really good at whatever subject it is are really good at the fundamental basics. They understand when I talk about gravity really well what the core basic definition of gravity is. All right. Anywho, I love this kind of stuff. I'm stopping sharing. So that's what we're doing today. Once you've done that, your job is really to take your time on this. Okay. I'm going to give you a copy of everything. You know what you need to do. You need to put your name on. Oh dear, it's disappeared. So your name on every piece of work in huge letters so I can see it from space. All right. Oh dear. And I'm just going to share that screen. Oh, my itchy nose. It is. Oh, that I said that. There we go. Pin that. Oh, I need to stop the recording. Stop recording. Right. So what